In the previous lesson, we had solved the system of linear equations by graphing them. In this one, we're going to solve them algebraically. What we have is we have two methods that we use. We have one method that's called substitution, which you're probably all familiar with, and then we have another method that's called combination or elimination, depending on which book you're using. We're going to probably call it combination because the Algebra 2 book that accompanied we used for a while used that terminology. One thing to remember is after you get your solution algebraically, you should always check it back in the original equations to make sure those equations are true and that it is actually a solution and that you didn't make a mistake. So the first one we're going to talk about is the substitution methods, and here are the sequence of steps listed out. One, you're going to solve for one of the variables of the equation. That means you're going to get one of the variables and you're going to isolate it, like x equal y equal. Then you're going to dump that variable back into the other equation and you're going to solve it, and that will give you the value of the variable. So we're going to see how that works. But first, I just want to make a comment that the substitution method works best when one of the variables has a coefficient of 1. And you'll see that in a second. For example, in this example I'm going to do, you notice that we have a 3x, a 4y, a 2y, but this x here doesn't, it has a coefficient of 1. So it's going to be easy to isolate, and when I isolate it, it's not going to have a bunch of fractions in the equation. Otherwise, if we had like a 7 on this x, we would get, like fractions like 2/7 and stuff like that, which make it pretty cumbersome, and we probably would use the combination method. So these type of equations are good for substitution, like I said, because here this x really has a coefficient of 1 on it, 1x. So it's going to be easy to isolate. So that's the equation I'm going to pick to isolate. So that's going to be x plus 2y equal to 2. Let's get the x all alone. X is equal to a negative 2y plus 2. Okay, so now that I have set that equation, it's the same equation, but I have it set now so that x is equal to the other side of the equation. I'm going to take this value of x and I'm going to dump it into this equation for that value of x, because at the solution point they would have to be the same. So let's do that. So when I substitute that value of x, I've got 3, and now I'm replacing the x in this equation with my value of x that I have come up with when I isolated. So that would be a minus 2y plus 2. And if you had more than one x in this equation, you would have to substitute it in for every value of x. Plus 4y is equal to a negative 4. Okay, so 3 times a negative 2, that's a negative 6y. 3 times a plus 2 is plus 6. Now I have my plus 4y is equal to a negative 4. Combining my y's, I have a negative 6y and a 4y. It's a negative 2y plus 6 is a negative 4. Subtracting this 6 from both sides, I would get a negative 2y is equal to a negative 10. Dividing both sides by a negative 2, I would get y is equal to a negative 10 all over negative 2, which is equal to 5. So I found my value of y. And now then I need to substitute this value of y into one of my original two equations, or I could substitute it into this equation here that I obtained when I isolated the x, and that looks like that's going to be a pretty easy one to find a x value for. So let's put the y in there. So I would have x is equal to a negative 2 times the y value, which is 5, plus 2. X is equal to a negative 10 plus 2. X is equal to a negative 8. So what I have is I would have my point of intersection would be a negative 8, and that's my solution where they cross. Now technically I'm going to try to make it so that I don't have a long video time, so if I would check my answers into all of these problems I'm going to work, it would extend the video, so I'm not going to do that, but you should put that point in the two equations and see if it works. Okay, let's try another substitution. And what we can see here is actually the y's are already isolated in here. So even if I had one y isolated, I could substitute it into the other equation. So since these are already isolated, I'm just going to take this value for y, which is 6x plus 8, and I'm going to dump it into that value of y. So when I do that, I would have 6x plus 8 is equal to a negative 5x minus 14. So let's move this 5x over to this side. And that would add by adding 5x to both sides. Sorry about that. I hit an icon and another program opened. So moving the 5x over, I would have 11x plus 8 is equal to a negative 14. Now subtracting 8 from both sides to isolate the 11x, I would have 11x is equal to a negative 22. If I divide both sides by 11, I get x is equal to a negative 2. So there's my value of x. And I could substitute that value into either of these two original equations to get a value of y. So let's take the one that says y is equal to 6x plus 8. Y is equal to 6 times a negative 2 plus 8. Y is equal to a negative 12 plus 8. So y would be equal to a negative 4. So my intersection point would be negative 2 for x, negative 4 for y. Okay, the second method is called the combination method, and this works well for any kind of a problem, but we definitely want to go to this method when we have problems that have big coefficients or coefficients on the in the equation, like this one here. We have a negative 10x, 3y, negative 9x, negative 3y. That's going to be one where if I did substitution, I'd get a lot of fractions. And so let's try a different method here. And here are the steps for that method. And what it's based upon is the fact that I can multiply any of these equations by any number. So I multiply the left and the right-hand side by the same number. And as long as I do that, I don't really change the value of the equation. I don't change the way the graph looks, and I don't change the values of x and y that make it true. So by manipulating the equations that way, I can find their solutions. And so the steps are listed up here, and you can see those. But it's probably just better if I start working an example, and you will get you'll understand what I mean. Okay, so here's the first kind of a problem. And when we do this, we're not going to really need to multiply anything. What we're going to do is if we can add or subtract these equations, what we're trying to do is get one of the coefficients to drop out. So I'm going to add these two equations together, and as you can see, I have a plus 3y and a minus 3y. What's going to happen is the y term will drop out, and then it'll allow me to find x. So this is a case where I really don't have to multiply any of the equations, so let's give this a shot. 10x plus 3y equal to 8, minus 9x minus 3y equal to 30. So now when I add these two equations together, I'm going to get a negative 10x and a minus 9x. That's going to give me a negative 19x plus 3y minus 3y. Well, the y's, that's going to be 0y, so the y terms drop out. 30 plus 8 is 38. Dividing both sides of this equation by negative 19, I get x is equal to a negative 2. So there's the x value. Now to find the y value, I need to substitute this x equals to negative 2 into one of those two equations. So I'm just going to pick the first one and figure out what y equals to. So a negative 10 times the x value that I found, which was a negative 2, plus 3y is equal to 8. Negative 10 times a negative 2, that's going to be a positive 20, plus 3y is equal to 8. Subtracting 20 from both sides would give me 3y is equal to a negative 12. Dividing both sides by 3, I would get y is equal to a negative 4. So my intersection point would be x at a negative 2, y is a negative 4. This problem is a little bit more complicated in that I am going to have to do a multiplication step. You can see that there's the negative 3x and the 8x. If I add those together, I would still have, that would be 5x. And the same thing for y's. I can't get rid of the y's by adding, but what I can do is if I take this first equation and I multiply it by 2, the whole equation by 2, that would give me a negative 14y, which when added to this 14y would make the y coefficients go to 0. So let's do that. So 2 times this negative 3x, that's a negative 6x. We need to be careful that the 2 multiplies by every term in the entire equation. 2 times a negative 7y, that's a negative 14y. And 2 times the 3 is equal to 6. So I've rewritten the first equation. It's still the same equation, but it looks different, and there it is. Now the second equation, let's add those together. So I have 8x minus 6x is 2x. The y's drop out, and I have equal to negative 16. Dividing both sides by 2, I get x is equal to a negative 2. X is equal to a negative 8. Okay, let's find y. So to find y, I need to take this value of x equal negative 8 and substitute it into one of my equations. I'm going to just pick the first one since the numbers look smaller. So a minus 3x minus 7y is equal to 3. A minus 3. Now the x value is a negative 8. Minus 7y is equal to 3. 24 minus 7y is equal to 3. Subtracting 24 from both sides, I would get a negative 7y is equal to a negative 21. Dividing both sides by a negative 7, I would get y is equal to 3. So my intersection point, the x value is a negative 8, and the y value is 3. And we should put, when we write the answer, write them as a point, because that's really what's occurring is they're intersecting in one point. Let's do the next one. Example. Once again, we can see that if I just add these like they are, neither the x nor the y will cancel out. But if I can take this equation right here and multiply it by a negative 2, that will cause this y to be a negative 2, and when I add it to the first equation, then the y terms will drop out. So let's go ahead and try that. The first equation doesn't change. The second equation will be a negative 2 times a negative 4x. That's positive 8x. A negative 2 times y is going to be a negative 2y. And a negative 2 times a negative 13 is a positive 26. Let's add those together. So negative 8 plus 8 is 0x. Negative 2 plus 2 is going to be plus 0y. Negative 26 is going to be 0. So at first, the whole left side of this 0x plus 0y is going to be 0 equal to 0. Now, at first thought, you're going to say, well, that's a no solution, but it's not. Anytime I have a number equal to another number and the numbers are the same on either side, that's true for every situation. So 0 equal to 0 is in fact true for every value of x and y, so this would be an infinite solutions. To be a no solution, we would have to get something like 0 equal to 4, something like that. That would be a case where it would be no solution because that is not true for any value of an x and y. Now, that's not what we had here, but I just wanted to let you know that 0 equal to 0 is in fact true for every situation. Now we're getting a little more complicated here. You can see that from looking at the coefficients, 3 and a negative 4, negative 5 and 2, there's nothing that I can do that's going to be really easy to get rid of the coefficients with just one multiplication step. So I'm going to have to multiply both equations by something. And it doesn't matter whether we try to get rid of the x's or we try to get rid of the y's. So I'm just going to pick the y's. And so if I multiply this first equation by 2, that you can see that that's going to give me a negative 10y. If I multiply the second equation by 5, then that would give me a positive 10y. So when I add the equations together, the y's would cancel out. So let's go ahead and do that multiplication. 2 times 3x, that is 6x. 2 times a negative 5y is a negative 10y. 2 times 4 is 8. Make sure you multiply the whole equation. Multiplying the second equation, I have 5 times a negative 4, that's a negative 20x. 5 times 2y is plus 10y, and 5 times a negative 10 is a negative 50. Adding those together, I get a negative 14x, my y's drop out, and a negative 50. Wait a second here. That looks better. Negative 50 plus 8 would be equal to a negative 42. So if I take and I divide both sides by a negative 14, I'm going to get x is equal to 3. Now taking this value of x equal to 3 and substituting it back into one of my equations, I can find y. So if we have 3 times the x value of 3 minus 5 times the y value is equal to 4. 9 minus 5y is equal to 4. Subtracting 9 from both sides, a negative 5y is equal to a negative 5. Y is equal to 1. So the point of intersection is 3, 1. Okay, the last example, once again, it's got some pretty big numbers in there. So let's figure out what to do. I think I'm going to get rid of the x's. If I multiply the first equation by 2, that will give me 30x. If I multiply the second equation by 3, that will give me a negative 30x, and they should cancel out. So let's go ahead and do that. 2 times 12 is 24. 2 times 2 is 4. Okay, multiplying the second equation. 3 times a negative 10. 3 times a negative 8. And 3 times a negative 2. Let's add them together. Okay, 30 minus 30, 0x. 24 minus 24, 0y. And on the other side, we have a negative 2. 0x plus 0y, well, that's 0. Okay, here's a situation. We have 0 equal to a negative 2. That's never true for any condition, for any situation of x and y, so this is a no solution. That's it.